equals key twice, but you didn't. You may run across something like that. But eventually, rather rapidly, you stop making that mistake and you move on to this one. What's the problem here? Numeric equivalency, right. When we're not testing the correct equivalency. Now, you may be surprised to find out that this is a mistake I still make with some regularity. And before you think, how can anyone with brain activity above mayonnaise make this mistake with any frequency? The answer is, half of my job involves writing Perl. And then for the other half of my job, I have to write, anyone guess? PHP, yeah. Where you don't have necessarily that same kind of distinction there. So it happens to me, and I tend to go rather easy on students who make that mistake in the first few weeks of class. So what can we take away from this, little bit of a discussion about EQ versus equal versus equal? Well, come away knowing about humility, right? Know your place. If you are a senior programmer and you work with junior programmers, you're allowed to be fallible. That's okay. You're allowed to tell them, hey, look, this is a mistake I made. Don't make this mistake. That's how everyone becomes a better programmer. And, the fact of the matter is, anyone can make a typo. Sometimes when you make a typo, it's not necessarily going to be seen by a lot of people. Other times when you make a typo, it may end up being seen by a lot of people. Ooh. So, those are the basics. Let's talk a little bit about control flow. These tend to be slightly more entertaining. Here's an interesting submission that I got. How many of you are fans of the unless, else, if, else way of doing things? Some of you are. Yeah, when it's really late at night and I'm grading, I really don't like getting submissions like this. I call this the way of doing things. But I also...
I like it well enough that I banned in Perl 6.
Yes, banned in Perl 6. That'll make my grading easier. I got this one in a final exam submission. I'll give you a second to wrap your head around that one. The main problem here is I graded this on a small screen. It was not written on a small screen, and thus I was grading what you're seeing. And it was all those fancy little close braces that helped me figure out that this is really just one long conditional, actually, but yeah. There are a lot of problems with in-nested levels of if. Forget about the efficiency thing for now. Let's talk about knowing when it's the right time to deal with abstraction, right? If you find yourself with lots of levels of nested if, think about abstracting. It's probably okay. Now, if you're like me and you have these, weird-looking tab stop kinds of things that are going on, know that some people tend to use 4 spaces for tab stops. Other people use 8 spaces. How many of you have read Perl Best Practices? Right. What's the recommendation? 4 literal spaces. Now, I'm not going to tell you you have to do 4 literal spaces. That's a philosophy kind of choice that you can make on your own. But at least walk away from this knowing it's probably not a good idea to assume that your replacement will be editing your code on the same side screen that you wrote it on, or using the same number of tabs. So just be aware of things like that. This was another interesting example that I got. What's going on here? We have decided we really like tabs. It's not necessarily doing what you would anticipate it's going to be doing on the first one. Yes, I actually got that submission from a student. You may think I'm kidding, but no. So, what about this one? Who sees a problem here? What's the problem? Yeah, you've got an unattainable else. You will never actually get there. Now, a lot of times people see stuff like this and they go, oh, it's not like anyone's ever going to do something like that in production. The problem is there are ways to put that in production that are not always obvious. What are we doing here?
Well, what if they have negative PIDs someday?
What if you're on Windows? You might end up with negative PIDs on certain versions of Windows under certain circumstances. So yeah, this is one of those times when, you don't necessarily get an error message, but the code might not be doing what you expected it to do. The worst thing that you would run across here, though, is when you get the follow-up assignment that says, okay, in the event that you fail to actually fork, let's do something differently. And then you go in and you add all of that functionality where you think it should go. But it turns out to never actually get there. So yeah, that's one of those cases where paying attention to your control flow can sometimes be really important. So some of you may worry that a student who writes code like this would never be able to write a program that could be marketable, right? Anything that these people write, there's no way you could actually sell that. But I am here to tell you that, it's fine. I am here to tell you that there is a market for absolutely anything in this world. I am not joking. There is a market for absolutely anything. Do you believe me yet? Wow. So yeah, that's control flow. Now let's move on to some stuff I call, wait, what? I'm still not sure what that sign is. I've had 2 people tell me what it says, and I still don't get it. So at the risk of being somewhat politically incorrect, I'll show you some of the other code examples I've got from students, and we can talk about some of them. So sometimes students submit assignments when they expect they are accomplishing something somewhat clever. What are we doing here? We've created a subroutine called print with new line that prints whatever you pass it, sort of, and adds a new line. But it doesn't actually print everything that you pass it, just part of what you're passing it, right? There's 2 kinds of abstraction. There's over-abstraction and under-abstraction. Now well, there's actually more types than that, but we'll go with that for now. Beginning programmers tend to fall into the under-abstraction category. You'll have nested levels of if kind of thing, and you know, that sort of happens. But a lot of times advanced programmers like to over-abstract things or prematurely abstract things and stuff like that. Why is over-abstraction bad? Well, yeah, you may not end up needing it. And now somebody else has to try and fix your code, and they have to figure out why is this abstracted? Because there must be some reason, right? So I can't unabstract that, or I might break something. So yeah, it's sometimes a good idea to think about that kind of stuff. So if we go back to the code here, what is the proper way to handle this? Use modern Perl, say. Yeah, no, clearly the correct thing to do here is to shift the variable off of @ underscore. Now that was one of those places you were supposed to laugh. That particular comment, much like both under abstraction and over abstraction, well, oh, never mind. I'm not even going to say it. All right, so what about those times when you want to tell your successor why you did something in a certain way? How do we accomplish this? What do we use? I don't know what you use. I use documentation. This is how I come up with figuring this out. And my general rule of thumb is when in doubt, document. And if you've got way too much documentation, make it funny. Just sort of, now I understand not everything needs to be documented, right? There are some times that you just don't need to put it out there. And there are some people that don't like to be told that they need to document things. And you know, I'm not going to sit here and tell you you have to document everything. Instead, I will show you what my students have documented, and we'll see maybe what we can come away from this with. So here's a particular comment I got in an assignment submitted. How many of you have used this code? Yeah. How many of you wrote socket communications before we auto-flushed things? Right? Same idea. After having a somewhat lengthy discussion with Randall, I basically decided that this particular comment submitted by a student was in fact an appropriate way to document this function. That's perfectly acceptable. You know, I'm okay with Perl Golf if you are, but the fact of the matter is maybe it's witchcraft, right? I got this one. Sometimes documentation gives you a little bit of insight into the psyche of the coder at the time that the document was written, right? You know, sometimes they struggle with things, and you know, it's as a teacher of the language, getting a comment like this actually gives me a little bit of insight into how I'm doing as a teacher. So I sort of like to see these. But from the standpoint of a programmer who's about to push something into production, perhaps this is not the most appropriate use of the comment space that you could have there. Now, I actually require my students to document certain things, and occasionally I get documentation like this. So, sock adder in does something with the port and modified server address. Okay.
Great.
Thanks. Okay, this documentation may not be needed. And it sort of leads me to this concept of documenting the why and not necessarily the what, if you know what I mean. It's like, if I already have that particular line of code, your comment is unnecessary. It's like bacon fries, okay? I have bacon. I don't need bacon fries. None of you guys like bacon, apparently. Oh, okay. I thought this was a fairly good example. But you know, it's one of those things where sometimes you run across the comments, you're expecting one thing, you get something else. It's not a good idea to give people something they're not expecting. That just tends not to generate the appropriate response from people. It's unnecessarily upsetting. So, occasionally the comments I get from students are more notes to me than they are notes to future self. I tend to recommend, if you're going to write a comment, write it for yourself several years from now when you're trying to figure out what on earth you were attempting to accomplish. But there are those cases where writing documentation, even for somebody else, gives you a little bit more insight into your code. I really wish I could have blown this slide up to show you, but it's a rather lengthy reason why this individual is not actually doing a particular bit of code. And he goes on and on and on and on until he gets to the very end and he says, "They'll come to think of it, I could have implemented that something in the time it took me to type this comment." So occasionally we get insights into our code from our own documentation. That's not a bad thing. Anybody ever found that documentation can substitute for some level of planning and get you to the point where you realize there's a better way to accomplish something, right? Yeah, so you know, it's not a bad idea when in doubt, document in paragraphs. But sometimes there are parts of your code where you really don't expect people to go. What's the classic example of this? Your object-oriented code, right? You want people to be using the objects, but you don't necessarily want people going in and mucking around with the inner bits of the object. Well, in that case, sometimes people will introduce documentation into that area that perhaps, okay, this is an interesting way to accomplish that. If you don't know what bless does, probably you shouldn't be monkeying around in the constructor anyway, so okay, I'll give you at least a smiley face when I return your assignment for something like that. But not giving documentation when it's necessary, that I don't like. I ran across this example. Who can tell me real quick what it's doing? Right. So here's what's going on. They decided they were going to choose a very appropriate variable name here to make it easier. No, this is from a tic-tac-toe game. And what they've done is they've created a hash that maps a numeric representation of the board to the row and column index of the array in which you can find the value, which is stored in the two-dimensional array. Right. I submit that perhaps formatting this slightly differently could have been really useful. How about formatting at 3 by 3 or even one long line or something that would have made it line up better? Yeah, that took me a while to figure it out. Now this is a digression, and I understand that. If you ever get to the point where you have to write code for a professor or for somebody who's going to be reviewing it later on, bear in mind that my interest in the line of code that you have written goes down exponentially proportionate to the time it takes me to figure out what that code was attempting to accomplish. If it takes me 5 minutes to unravel one line of your code, I'm not all that interested in giving you an A. You're supposed to laugh at that point. It's okay. You're like, no, you're a scary, terrible professor. I'm not going to take your class. That's okay. We could keep doing that. So some of my colleagues tell their students, just write self-documenting code. Your code shouldn't need any documents. And I know that there are some places where self-documenting code is what they're expected to do. The reason I require documentation is that not every place says self-documenting code is the right thing. So I want students to have actually been exposed to documentation before they get a job where they're expected to do it. Now, my big problem, though, with self-documenting code is the kind of documentation within the code that I get from students. It ends up not actually being code that's easily self-documented, and at best it's like directly relationally ironic to something, and you never quite figure out what it is they're attempting to accomplish with that bit of code. And so documentation really should be all about telling you why you're attempting to accomplish something, not what it is you're attempting to accomplish.
You can say that again.
No, I can't. I don't remember what I said. Anyway, so makes it a little bit easier for people who are reading it later on. If you're not talking about comments in the code, give funny examples. If you're interested in what that looks like, read the Camel book. There's all sorts of them in there. I chuckle at that all the time. But the fact of the matter is, if you can't figure out what a particular bit of code is doing in such a way that it's easy to document it, perhaps the better solution is to refactor whatever that thing is. Because let's face it, planning is a good thing. I have to assume that was done on purpose. Otherwise, I'm going to have an existential crisis. So, let's move on to communicating clearly. My father taught English for 35 years before he retired from the public school system, and he instilled in me this concept that dangling modifiers are dangerous. And his classic example of this was a particular thing that he read that said, having many dangerous curves, she drove carefully down the mountain road. I'm not sure you're conveying what you meant to convey in that statement. So, in as much as it happens in English, it also kind of happens in Perl. But continuing on with the English example, I had a student who came up to me after class one time and said, "What is a deck of cards?" Because we were going to be talking about an algorithm that shuffles cards and then deals a hand. And she said, "What's a deck of cards?" It took me a while to understand what she was saying. She was pretty fresh off the boat. It was an international student. And I actually keep in my laptop case a deck of cards because sometimes I get on the plane and I need to play solitaire or something to amuse myself. And so I went and I got them and I said, "This is a deck of cards. They look like this. You can deal things." And she said, "What is that? Can I see that?" I thought something was a language barrier, but it turns out where she came from, she had actually never seen them. And so I had to, at some point, at some level, explain what card games are and what a deck of cards is and what do they consist of and things like that. But it made jumping into the exercise quite a bit harder than I expected it was going to be. And so now that same assignment includes at the top, if you're unfamiliar with a deck of cards, here is the Wikipedia entry for this, here's the Wikipedia entry for poker, things like that. It's just sort of a way of figuring out assumptions I didn't know I was making, right? But then you've got the other students, not the ones that don't know what a deck of cards is, but the other ones. It turns out one of my students was a professional poker player, and he was not happy with a simple shuffle algorithm. He decided he wanted to write an algorithm that would do a realistic casino shuffle. And so he went through the trouble of doing it, and it had appropriate levels of abstraction, and it turned out to be, a really interesting assignment that he submitted. But you question your assumptions. Maybe you think people are at a certain level. Some of them are going to be below that level. Some of them are going to be above that level. So when you're attempting to communicate to the user what it is you want the user to do, I recommend being very concise and very precise in what it is your expectations and assumptions are. So, another example. We were doing client-server communications, and one of the things I told the student they could do was to run a server on the machine and then try and telnet to that port. If you can connect, that tells you at least the thing is running on that port. It's just sort of a convenient way to do your troubleshooting. So, the student opened up the Linux laptop, ran the server program on the laptop, and then SSH'd over to the server where they're supposed to be running all their code and said telnet localhost. And could not figure out why they couldn't see it. And I had to explain that localhost doesn't mean the machine local to your hands. It's the machine local to the code, wherever it happens to be running. She's like, oh, so I have to give it my IP address. So telnet 192, no. This is not the appropriate. SSH out and run the server on the server, and then SSH out onto the server and telnet localhost. And that just caused all sorts of confusion. Now, the prerequisite for this class includes the Unix class. So in theory, the assumption should have been appropriate that a student should know about these kinds of things. But, you know, sometimes people slip through the cracks, or they don't actually learn something in a class that you expect them to learn. So I learned very quickly to question assumptions. So yeah, the question is, what type of cat is this? Yes. So anyway, so let's talk about formatting. I had a particular assignment that I submitted to the students, and I said, you have to do X. They said, okay. I got a bunch of assignments back. I would run the code. It would take a second or two to run, and then it would come back, and it would give me my prompt, and I could grade what they were doing. So I ran one student's example, and I waited, and it never actually came back. And so I'm like, well, I'm going to go do something else. So I went to do something else, and I came back, and it was still sitting there, and I'm like, why don't I have a command? Oh, I do have a command prompt. You just didn't put a new line at the end of your program, so I didn't see the... Even a single character in your feedback to the user can make a difference between whether something is simple to understand or somewhat more complex to understand. When you get to the point that you want to communicate clearly about how you want the user to interact with your program, might be a good idea to think about things like that, test it with various things. What about user feedback? Well, sometimes when you're grading a whole bunch of assignments, the way you get user feedback from the program can surprise you a little bit. I was not expecting Zoidberg in the middle of a timeout routine, but I got it. You know, that's okay. That was kind of funny. But when you're choosing file names, that's a problem. See, I didn't used to care about file names. I used to tell my students, just call it whatever you want. As long as you upload it to the system under your account, I can find it. And then one assignment came back, and only one person bothered to include their name in their assignment. And they were all sitting on my machine while I was trying to grade them, and there was no comment saying who did what or anything. So I eventually was able to figure it out by cross-referencing thing in the course management system where they actually uploaded everything. But I decided, since they were going to give me such a hard time figuring out who had what, I would return their grades in a similar manner. So when I came back, I wrote all their grades on the board. And I said, have fun. They said, how do we know whose grade is who? I said, how do I know whose assignment is whose? Oh. And what we all learned that day was, don't make your colleagues become evil. That's a bad idea. I guess what I'm trying to say is be mindful of others, be considerate, be somewhat compassionate. Don't make people evil. More to the point, don't make people ask for directions. That's not always the right thing to do. It just makes them turn a little bit evil. That may be my favorite slide of all. I like that one. So, learning to communicate clearly. Don't make assumptions. That's a pretty good one. Here's a tip. If you're writing a Unix utility that dies, I recommend dying with usage, as opposed to just dying with insult. That's not necessarily the appropriate way to handle that. See, I had a student who decided he was going to submit 10 late assignments all together the day before the final. Okay, fine, I'll go through and grade them, and as I'm grading them, I get to this one, and I say, maybe not the best way to tell me which lab that was and what I'm supposed to be doing. Well, let's move on to efficiency. What's my time looking like? Oh, wow, we're doing great. Okay, so efficiency. There are other talks that are all about efficiency, and some of them are really, really good about efficiency, and most of those people are way better at efficiency than I will ever be. So I will tell you about certain kinds of efficiency to avoid, in the sense that somebody once submitted an assignment to me where they did not. Here's one of my surprising ones that I got in. Back to that tic-tac-toe example. I told people, pick a random spot for your, you're going to have a user play tic-tac-toe with you. Pick a random spot, but that spot has to not have a move already in it. It can't be an X or an O already. Okay, so here's the algorithm they came up with. Pick a random spot and see if there's something there. If not, do it again. Now, when you only have 9 things to check, and let's say there's already 8 moves, it's pretty obvious what the last one should be, and you may cycle a few times, but the fact of the matter is it's going to appear to the user as though this all happened instantaneously. But what happens if you have 9 billion records and you use an algorithm like this? It's probably not going to look instantaneous to the user. I'm just guessing on that one. So
like it's got an off by 1.
What's that? Off by 1?
Are there 9 places to move?
1 through 9?
Yeah, but random data is going to.
Yeah, give 0 through
You're right.
0 through 7.
They didn't actually want to put something in one of the spots, I gather? Yeah.
Well, everyone knows you should just go on the center square first.
Yeah, even if there's something else there. I actually had someone's code who did just that. They didn't care whether there was something there or not.
If the last move, a possible move is in square 9, it's going to loop forever.
That's true. That would take a long time.
Not run this game.
Yeah. I will not let you win. Yeah. So here's another particular part of efficiency that we were talking about. Now, I assigned a program where we were going to sort of monitor what was happening with top in another window and see how how forking works with processes and how these things work out. And so, okay, we're going to go ahead and we're going to die if we can't fork. But if the process ID is 0, then what does that tell us about this particular branch? We're the child process, right? Because kid PID is 0. So we're going to kill off the child, and then we're going to sleep for a second, and then the parent's going to spawn another child. And so this is how we were supposed to be doing things. Well, one of the students who submitted an assignment did something a little bit differently, found some code online, and submitted it like that. What's going to happen now? Fork bomb. Yeah. They were really surprised when this one didn't work out quite the way they were expecting. And they said, how come when I run my script, for a few minutes it looks like things are happening, but then my terminal session hangs? Yeah, the reason your terminal session hangs is that we set a fairly low proc limit on the server, because you might do something like this. So yeah, the other side of it that I came across was one of my students who said, well, but I don't have to worry about that. I'm on OS 10. You can't fork bomb OS 10. I said, oh, really? Do a Perl-E fork while fork. And he's like, okay. And what he didn't remember was that on his laptop, at the terminal, he was logged in as root. And he ran that code. Guess what his laptop did after that? Nothing. That's exactly what it did after that. He couldn't get the mouse to me. He got nothing. Yeah, that was a hard power off on that one. So, efficiency. Even one character or two can make a huge difference in efficiency. So, let's see, conclusions. Are we out of time yet? No. Should we be? Yes. What's that? 20 minutes. Wow, you guys are going to have all sorts of free time after this one, so you can ask me any kinds of questions you want. Okay, so, conclusions. Thank you for letting me vent. I enjoyed doing it. Be patient with people who are submitting code that's maybe not at the level of your code. That's okay. Be kind to people. Be humble when you're interacting with people that submit code. Use your coding powers for good rather than for evil. And I hope that at some level, I've sort of changed your perspective about a few things. Because the first time you try and do something, even if it's a relatively simple task, it's possible to mess it up. Wow. That was a big poster in a train station. It's hard to see when you blow it up. They just move the pages around. But yeah, don't leave your coworkers looking for a paddle. So, questions? They don't know that idiom, they don't get the joke. Okay, I'm sorry. It was the best I could come up with for an ending to that talk. No questions? Okay, well, thanks.